the particular concept of shear center. So in analysis of mechanical element or in solid mechanics or in this advanced stress analysis, this part of shear center is most probably required to study, and that too useful for the beam elements. Means number of times what happens, that number of beam elements in which thickness of material is always small, okay, and which is considered to be thin walled section. Number of times in case of this analysis of mechanical element or in solid mechanics, we are purposefully giving the reference of thin walled sections because these sections are very useful in general for construction purpose, for fabrication purpose, for stress point of purpose, or for truss type of structure. Is it okay? For truss structure, this is number of times required. So the thin elements that we are referring, number of beams in which the thickness of material is small compared to overall geometry of the section, these sections are called as thin walled and again open section. Is it okay? Purposefully word I will have to mark here is thin walled and open section. So when such a beams is subjected to many static force and due to force, bending moments and shear that simultaneously occurs inside such a thin elements. Now precisely saying these kind of thin elements, so for that purpose angles, C sections, I sections, square bars, all these are thin sections. We are using this probably for construction of stress element or to give the support. A number of times the way of construction in which the girdle, this word is used, number of times girdle word is used. Girdle. So girder is the type of thin section only. Is it okay? So many times we are observing that whenever the roof is generally constructed, suppose slab is there, no problem. Another case, when girder is used, then plates are used, or in some sections when sheets are used, metal sheets are used, then in order to support such a metal sheets, the thin sections like angles that are used below these thin sheets. Is it okay? So whenever sheet concept is there as a roof, as a part of roof, when sheet is used, then to support these sheets, angles are used, and that angles that are in general are considered to be thin walled sections. Is it okay? So thin walled open section. We are considering this as thin walled open section. So number of times I sections, then angles, C sections, Z sections, channels. These are the examples of thin walled open sections. Is it okay? But when such a beams are subjected to static force and due to force, bending moments and shears are present inside this kind of sections, then to avoid twisting and to cause only bending, the transverse force must act through a point, and this point is called as the shear center. So try to understand the concept. This concept is very, very important. Shear center, this concept is very, very important, and that must be known to you first of all. Is it okay? So let us try to understand the concept of shear center first, and then we will go ahead for its derivation. Is it okay? Two things are there, out of which one is twisting and second one is bending. So when bending happens, then no issue because the thin sections are more bending resistant. Is it okay? Thin sections are more bending resistant. But if the case happens that twisting is happening, then these are very, very weak in case of twisting. So for these thin sections, in order to have bending, but to avoid the twisting, the requirement is that whatever the load is acting on such a thin sections, that should be act through a point, and this point is called as shear center. Is it okay? Are you getting concept? Are you getting this concept? हा concept लक्षात येतोय का?
Yes, sir.
Okay. So we have to avoid the twisting and we have to go for the bending only. Is it okay? To carry out the bending, but to avoid the twisting, whatever the point we are identifying, so that point is the shear center. Is it okay? So this is the point inside which the force is applied, then that will be purely bending type of force. But besides this, the force acted will be more prone for twisting of this particular section, and due to that twisting there will be more loss of that beam, and the life of that material will be very, very small. The failure of that section will happen suddenly. If twisting happens, then material failure will happen suddenly, and if bending happens, then the life of the material will be larger. Is it okay? So considering that things into mind, the concept of shear center is required to study. Is it okay? So why there is necessity to study the concept of shear center? So this is the necessity to study the concept of shear center. Is it okay? शेयर सेंटर हा पार्ट का स्टडी करण्याची आवश्यकता लक्षात येते? आर यू अवेअर? तुम्हाला लक्षात आलं की वाय टू स्टडी द शेयर सेंटर? Okay. Okay, now refer the figure which is in front of you on this display. So see, in this figure, now this particular section is shown here. Is it okay? This is the channel, and on this channel, so here we are observing the various dimensions are present. Three mutually perpendicular axes are present here. You can observe this particular channel section. In this channel section here, this particular axis we are considering to be x-axis. This vertical axis we are considering to be y-axis, and this one is one third, that is z-axis. So x, y, and z-axis are three mutually perpendicular axes to each other. Suppose This is height. Then this height is shown by this notation h. So small h notation is used in order to represent this height. Is it okay? Then this t is this t is used in order to have the thickness. Is it okay? So t, see here, t is the thickness. Here you can understand this h is the height. Is it okay? Three mutually perpendicular axes we can refer here. X is the axis, y is the axis, and z is the axis. Is it okay? All these three axes are mutually perpendicular to each other. This height h, we can see here that h parallel to y, so that is the height. Then thickness is here in vertical direction again. So this particular thickness is noted by this t, and the small portion which is cut along this z axis, is it okay, here, that is shown by this delta z. So small portion, this is along axis z, the small element along this z is delta z. Is it okay? So three mutually perpendicular axes x, y, and z, out of which this h is the height, then t is the thickness, and delta z, so that is the small element considered along the direction of z. Now small strip is shown here. You can see here, this is the small strip which is shown here. Is it okay? This small strip, so which is along this b. Is it okay? So b will be considered to be width. B is width, h is height. Then the dimension along this z axis, which is shown here, it is by delta z, and thickness of this section is shown by t. Is it okay? So try to understand the various dimensions of this particular thin section. The thin section which is chosen here, that is channel, and here x, y, and z are three mutually perpendicular axes to each other. Then this h, this b, this delta z, and this t, what is meaning of that? And that we should understand first before going further. Is it okay? So we have understand here that t is the thickness, b is the width, this delta z is the small distance along this z axis, and the small slit which is chosen here, and h will be considered to be height. Is it okay? So this z axis, along this z axis, there will be the length of this particular channel section. Is it okay? That we should understand here. Is it okay? So these dimensions we are going to understand here. Now, if we consider this arrow, there are two kind of arrow. So this arrow is vertical arrow, and this particular arrow is horizontal arrow. Is it okay? So this horizontal arrow is shown in this top portion. This horizontal arrow is shown in bottom portion. So this top portion of this channel, this bottom portion of the channel, and this is vertical section of the channel. Is it okay? In this vertical section of the channel, this arrow is in vertical direction. In this top portion of the channel, this arrow is in horizontal direction. So this is regarded as horizontal stress flow. Is it okay? So this particular arrow is regarded as horizontal stress flow, and this vertical arrow is regarded as vertical stress flow. Is it okay? So this horizontal and vertical stress flow that we should understand here. Is it okay? Then let us go for shear center. Once again, we are going to use here the flexural formula. So all of we know what is meant by flexural formula. What is meant by flexural formula? Anybody? What is meant by flexural formula? What is flexural formula? Anybody? Anybody? What is meant by flexural formula? Yes. What is mean by flexural formula? Okay, what is mean by bending equation? Anybody? What is mean by bending equation? Are you listening or not? All of you are listening or not listening? तुम्ही सगळेजण ऐकताय का?
Yes, sir.
हा, ठीक. आपल्याला आठवत असेल, in strength of material we have seen this bending equation or we have derived this equation. आपण याचं डेरिव्हेशन जे आहे ते आपण सेकंड इयर मध्ये ज्यावेळेस अनालिसिस ऑफ मेकॅनिकल एलिमेंट किंवा स्ट्रेंथ ऑफ मटेरियल हा सब्जेक्ट ज्यावेळेस आपण शिकलो होतो त्यावेळेस हे इक्वेशन जे आहे ते इक्वेशन आपण डिराईव्ह केलं होतं. एम अपॉन आय इज इक्वल टू, इथं आपण काय वापरलो होतं? सिग्मा वापरलो होतं नोटेशन. इज इट ओके? एम अपॉन आय इज इक्वल टू सिग्मा अपॉन वाय इज इक्वल टू ई अपॉन आर. इज इट करेक्ट? आठवते?
Yes, sir.
हा. So m upon I, sigma upon y आणि e upon r. Where what is m? यातली m काय आहे? आठवत असेल तर सांगा. What is m? m is
Moment of inertia.
Sir,
m is
bending moment.
bending moment. m is bending moment. आणि हा I जो आहे हा I मात्र
Moment of inertia.
moment of inertia. Is it okay? I is moment of inertia. So m is bending moment, I is moment of inertia. Here notation F is used, but we supposed to use the notation as a sigma. Is it okay? In second year, whenever we have used this notation, here we have used the notation as a sigma. And what is that sigma? तो sigma काय होता किंवा इथं असणारा हा F काय आहे?
Stress.
Stress आहे. Is it okay? Then this
F
Y.
upon E, sir.
What is this
Young
Y?
Young modulus.
Y is
Young modulus.
Reflection, sir.
Y is here.
Young
Distance
modulus.
from 9. E हा Young's modulus आहे. E जो आहे ना हा Young's modulus आहे. Y काय आहे?
Deflection, distance from the moment of center or the mass center.
Distance from neutral axis. You are right.
Okay.
Distance from neutral axis. त्यामुळे neutral axis हा जो concept आपण वापरत होतो त्या केस मध्ये. So that Y is distance from neutral axis. Is it okay? So bending moment, moment of inertia, M is bending moment, I is moment of inertia, F is stress here, Y is distance from neutral axis, E is Young's modulus, and R is radius of curvature. Is it okay? So M upon I is equal to F upon Y is equal to E upon R. Bending moment, moment of inertia, stress, distance from neutral axis, Young's modulus, and radius of curvature. Is it okay? So this is the bending equation, or it is also called as flexural formula. Is it okay? So this is the flexural formula. Now we will take the condition here into consideration that M upon I is equal to F upon Y. Is it okay? Now in previous figure, we have seen that in this figure, there were two kind of stress flows. One stress flow was horizontal stress flow and second flow was vertical stress flow. Is it okay? So vertical stress flow, the notation used for vertical stress flow may be but in horizontal stress flow, the notation used is Q. Is it okay? So the horizontal stress flow, for that notation used is Q. So he stress flow, this F notation which is used previously in this particular equation, F upon I is equal to F upon Y. This F, that is nothing but the stress, and horizontal stress flow, this particular concept for which the notation used is Q. So Q is regarded as horizontal stress flow. So which is written here, that F is replaced by this Q, and this Q is the notation for horizontal shear stress. Is it okay? So this Q is horizontal shear stress, because in this figure, if we try to understand here, this arrow and its equivalent opposite arrow is present here in the top section. This is a horizontal arrow. This bottom section, this one is the horizontal arrow. So equivalent opposite, these two arrows, that you can understand here. Is it okay? So these two arrows will form the shear center. So it is a horizontal shear center. M upon I is equal to Q upon Y. Is it okay? Are you clear?
Yes, sir.
Okay. Now, as far as concerned with this horizontal shear stress, now let us consider that for small case, here we are always considering, for our, whenever any equation we are deriving, always we are considering the equation for small element. Is it okay? So here you can consider this is the small element, and for this small element, now initially we will apply the equation, and then we will take summation of all such elements and we will derive the equation for whole section. So from that point of view, here we are going to generate the equation for this horizontal shear stress. So this Q is horizontal shear stress, and it may be My upon I. It is My upon I. But this delta is used because we are using this particular equation for this small section. From this we are going to start, and that is very small. That's why notation used is the delta. Is it okay? So Q is delta My upon I. That we should understand here. So using the word delta, using this notation delta, is that is applicable for smaller section. That's why this is used. Then here small arrangements or small mathematical terms that are used, or mathematical operations that are used. Inside that, the first operation used is that it is multiplied by area. So when this particular stress is multiplied by area, this is going to get convert. This is going to get converted into stress into area is what? Stress into area is force. Stress is equal to force upon area. That's why. Is it okay? So here, by multiplying by area. So on both side of this equation, it is multiplied by area. So Q into area is equal to delta M upon I y into this area. Is it okay? Then now as far as concerned with this thickness T and this delta Z. So T into delta Z. So this particular area here you can see this particular section is taken into consideration, and its thickness is T and this particular length is delta Z. So if this multiplication T into delta Z is carried here, so T into delta Z, so that is carried here T into delta Z. Is it okay? So area is multiplication of this T into delta Z. So Q into T into delta Z. Here you can understand this. Q into area is nothing but Q into T into delta Z. Is it okay? So on both side it is multiplied by area, and after multiplication we will get, so Q into T into delta Z is equal to delta M upon I into Y into dA here. Is it okay? Then again this T into delta Z, so that term is transferred to the right side. So after transferring this term to the right side, we get Q is equal to delta M. So delta M which is present here, T is transferred here, delta Z is here, and into this Ix is present here. Okay, so this I is the moment of inertia which is present in this equation. Delta M already present which is here, this T into delta Z which is transferred here, I is present which is present here, and Y into dA. So only this T into delta Z, so that is transferred to this right side, and this equation for that Q is equal to delta M upon delta Z into 1 upon T into Ix into YdA. Is it okay? Now here you can understand that delta M upon delta Z. So this particular all of we know that derivation of this moment is nothing but force. Okay, we know the concept of shear force and bending moment already. In analysis of mechanical element, we have studied the concept of shear force and bending moment. So this force or shear force we will get after taking the differentiation of bending moment. So here the differentiation of bending moment has been carried in order to get the shear force. So Q is equal to this delta M upon delta Z is the F, is denoted by this F, into 1 upon Tix into YdA. So this Q is F into 1 upon Tix into YdA. Is it okay? So this particular delta M by delta Z, so differentiation of this bending moment, this dz, and then this Q total, for that this in order to identify the total value, always what we are doing, always we are taking the, what we are doing, always we are taking the integration in order to find the total value of this shear flow. Is it okay? So this shear stress or horizontal shear stress, total shear stress, for that purpose integration is taken from 0 to b. Now you can see here 0 to b means what? So initially this particular surface area we have taken into consideration. This was the surface area which is taken into consideration, and then this B is taken into consideration. So here, by using these two notations here, we have seen that 0 to B. Is it okay? So F upon Ti integration from 0 to B y dA. So F upon Tix y into this dA means now this is the area and this is considered to be B into T. So here you can understand this B is here and T is this thickness. So B into T. So this is the cross sectional area here. So B into T is used, this B into T. So that area B into T. So QT, that is horizontal shear flow, is equal to F upon Tix y B into T, and this is from 0 to B. So its lower limit is 0 and upper limit is B only. Is it okay? So like this, by substituting here F into Y, B into T upon Tix. So here you can understand here that this T get cancelled and whatever the remaining term inside which F, Y, B and this Ix is remaining. So Q is equal to FYB upon Ix. Here you can understand this particular equation. Q is equal to F into Y into B divided by Ix. Is it okay? Are you getting this? Are you getting this equation?
Yes, sir.
Equation लक्षात येतंय का?
होय सर.
So here this Q is equal to FYB upon Ix, and this particular equation for that, now this Y is nothing but distance from neutral axis. If we refer this figure, then the distance from neutral axis, so always we are considering this particular with reference to this figure. If this is H, this height is H, then with that H distance from, suppose this is the neutral axis is present here. Suppose here at the center, from this center the neutral axis is passing out, at this location neutral axis is present. Then from this central position up to the top here, if suppose this particular distance we are measuring, then that distance will be H by 2. So distance from neutral axis will be H by 2, and that is substituted here, which is substituted here H by 2. Then that becomes Q is equal to F into H by 2 into B, because this, in this equation we have seen that Y is nothing but H by 2, and which is substituted here F into H by 2 into B upon Ix, so which is here F into H into B upon 2Ix. So this is the horizontal shear flow. Suppose we are interested to identify the average horizontal shear flow. Then if this particular shear flow, if suppose this is the maximum value, then for average, if it is taken as minimum value is 0 and this as maximum value, then average shear flow, which is shown here. So this average shear flow is nothing but F into H into B upon 4Ix. So average shear stress is given by this one. If we are interested to identify average shear force, then we must multiply by area to this equation in order to get the shear force. Is it okay? So average shear force is nothing but this particular right hand side into its area. Is it okay? So F into H into B divided by 4Ix into area, and FHB upon 4Ix into this area is B into T, because with reference to this figure we know that B into this T thickness, so that is required to use here, and then by substituting that we are getting here that average shear force is F into H into B square T upon 4Ix. Is it okay? Try to understand this particular concept here, that F into H into B square T upon 4Ix. Is it okay? So this will be considered as the average shear force. Now this is average shear force. In order to identify the couple now, this particular force, equal and opposite amount of force is acting with certain distance. Couple is generated. So if we refer this figure, this is one horizontal arrow, this is another horizontal arrow, and in between these two horizontal arrows, the distance is h. So with that difference distance h, and with these two arrows, this force is going to act, this couple is going to generate, and that's why with these two forces and with this h distance, here we have considered that in order to have the couple F H V square T upon 4Ix, so this particular force, and this is the distance H, then couple is given as F into H into B square T 4Ix into H. H is the perpendicular distance between two forces. Now this F and this F, that is cancelled here, and then this distance E is identified, which is considered to be shear center. Is it okay? So the E is given as H square B square T upon 4Ix. Is it okay? So E is given as H square B square T upon 4Ix. Here you can understand this. So this particular H square B square T upon 4Ix, this is nothing but the shear center. Is it okay? So E is given as H square. If suppose this kind of channel for which H is regarded as its height, T is regarded as its thickness, B as its width, then shear center in that case is given as H square B square T upon 4Ix, where I is moment of inertia with reference to x-axis. Is it okay? Is it okay, all of you?
Yes, sir.
Any doubt? Any doubt